so this is the notes for section 5.2, where we're going to look at solving systems using tables and graphs. So what we want to do today is we want to use the technology that we have available to us to solve systems of equations. Now remember, when we're solving systems of equations, what we're trying to do is we're trying to find the ordered pair or pairs that make both or all of the equations within the system true. So keep that in mind as we're going through and solving that. So graphically, if we use our graphing calculator to do that, really what that means graphically is we're looking for the intersection of the graphs. Where do the graphs share points, basically? So what I'm going to do is I'm going to go through this first equation using your graphing calculator, so you might want to get that out and get that ready to go. And these are the steps that I'm going to use to go ahead and solve that equation. So we have these two equations, xy is equal to 6 and x minus y is equal to 5. Now neither of them are solved for y, so we're going to use that. We're going to have to do that first of all. So if I'm going to solve this first equation for y, what I'm going to do is I'm going to divide both sides by x. So really what I'm left with, excuse me there, what I'm left with is y equals 6 over x. And in the bottom equation, if I solve that for y, that would be the same as saying y is equal to x minus 5. Okay, so if I solve those two equations for y, that's going to help me when I put them into my calculator. So now I'm going to come over here and I'm going to start by adding a graph, and I'm going to type in those two equations. Okay, so I've typed in y equals, remember, it's just f of x instead of putting the y in, and that will graph that equation. And then I can hit tab to get a second equation, and this time I'm going to write in my equation x minus 5. Okay, so we now have both of those graphed, and as you can see, there's two places where the graphs intersect, right here and also right here. Okay, so the next thing I want to do is go ahead and find what those values would be. So I'm going to go ahead and I'm going to go down to geometry, points and lines, intersection points. And then all you have to do is select the two graphs. So I'm going to select this blue graph here and the red graph, and as soon as I do that, you'll notice that it brings up those points. So one point is -1, -6, and the other point is 6, 1. So those are the solutions to that system, and we found them graphing. Alright, so I'm going to write my answer then to those two questions, which I'm going to write as a set of values, because there's two ordered pairs, and the two ordered pairs are 6, 1 and -1, -6. And generally when we're going to write a set, we're going to write that in brackets like that. Now you could also just write just those two ordered pairs, or you could even write it like this. You could write x equals 6 and y equals 1, and then write and then another system like that, x equals -1 and y equals -6. Either one of those would work in terms of how we write our answers. Alright, the second system that I have here I'm going to solve graphically, but this time I'm going to use Desmos to do that same process, and it doesn't really matter which way you do this. So I'm going to come over to Desmos, and one thing that is nice about Desmos is it actually doesn't matter how we enter these equations. We can enter them actually just as we see them, at least for this part. When we get to the table part, it'll be a little bit different. But I went ahead and entered those two equations. So y equals x squared over 4 minus 1, and then x plus y equals 2. So I didn't even have to have this one solved for y. I can leave it in the standard form that it is, and it will graph both of them. Okay. Now you'll notice that when you do that, if you just click right on where the points intersect, remember you can pull or zoom out also, it will actually bring up where those points are. So I'm going to zoom out a little bit so we can see them both. And you'll notice that the 2 points are 2, 0 and -6, 8. So we can easily find those two values by graphing it using Desmos as well. Alright, so I came over here now into our notes and added our solution. Now remember what that means. That means this is the set of ordered pairs that makes both of these equations true. Okay, it's the only two ordered pairs that make both equations true. All right, another thing that we can do with both of these technologies is that we can use what we know about the functions and create tables as well. Now, the nice thing about tables, it gives us exact ordered pairs that satisfy each of the different functions. So I'm going to show you how to do that on your Inspire, and then also how to do that on Desmos as well. So we're going to come over to Inspire Calculator with the graphs that we already have there. And there's a very easy way to do it. Once we have things graphed, we can come up here and we can go to Table, so Menu and then Table, and then you select Split Screen Table. And what it does for you is it will bring up a table of values that matches the graph that you have here. So I'm going to just make sure that we have those, move this over here and move this one, if I can grab it here. There we go. Move this one closer to this function here. Okay, so now we have our different values. Now you look on your table, you can go roll, you can go up and down on your table and see the different values. You notice how we have at 0, it's undefined, which would make sense. And then finally, what we want to do is we want to find where they're equal. Well, notice at -1, both f1 of x and f2 of x are both equal to -6, which would make sense since that's the point where they are intersecting. Okay, we can also go to where x is equal to 6, and you'll notice that they're both equal to 1 there. So we can see it on the table as well. So it's fairly easy to add a table to analyze that a little bit further. Now, one other thing I want to talk about with the tables is if you have to go up to at a smaller rate, or you want to change that, you can always go to Edit Table Settings, and you can set your step rate, so how much is it going up by each time, and also where you want to start your values at. Either that's just some settings that you can play around with. Now we can add tables to Desmos as well, and it's not quite as intuitive as it is on your calculator, but you just go to Add a Table, and what you can do is instead of x1, we're just going to put x here, and instead of y1 over here, so I'm going to click here, I'm going to get rid of this, and I'm going to put my equations once they're solved for y. So on the first one, I'm just going to put x squared divided by 4 minus 1. Okay, and then I'm going to, over here, I'm going to put, if I solve this for y, it would be 2 minus x, or -x plus 2. So I'm going to put that in here. Okay, so now I've got my two functions in there. Now what we can do is we can enter a starting value and then how much we want it to go down by. So let's say I start at -8. Okay, and then what I can do, if I hit enter, I can put another one. Let's say I go -7. Now I can continue to enter, and it will just generate values every going up by 1 each time. Okay, and you'll notice by doing that we can get our two different values where they're equal at -6, 8. Notice how the functions are equal, and at 2, 0, 0 they're equal as well. Now it could be, and I'm just going to go back here. I can go up by less each time. So let's say the values weren't nice neat numbers. We can go up by say 0.1 instead. So I can go -7.9 here, hit enter, and now it will go up by 0.1 each time. So you can always change how much you want it to go up by, instead of it always going by 1. All right, finally, before you come to class, if you could try this example problem. I'd like to see all of your work on your notes. I'd like to be able to see that next time when you come to class, and then see what you can come up with. You're going to have a system of equations that you can solve. Once you get that system, try either using Desmos or your graphing calculator to solve that system, and then we'll take a look at that particular example in class next time. Okay.